Now that we're done with the discussion about the indifference curve, which tells us the preferences of a consumer, because we saw an indifference curve is plotted by looking at people's preferences and ranking, we're good to talk about the affordability part, because if you want the demand to become effective demand, not only you want willingness, but you also want ability. So a budget line is useful because it actually helps us understand the affordability, because it shows us the combinations of two goods that an individual is able to consume at a particular prices with a given level of income. So let's go back to the example that we had earlier of somebody who was thinking of buying apples and oranges. Let's say this individual has an income, let's call Y as income of $100. And let's also assume that the price of apples is, for example, $4 per kg, while the price of oranges is, for example, $2 per kg. Now, if he decides to buy only apples, if I say all of his money, let's say, is spent on apples, that's one combination, which means for only apples and no oranges, then one would argue this that the amount of sort of apples he can buy will be simply income y over price of apples, because that's what he's spending, or 100 over 4, or for example 25 kgs of apples. On the other hand, if he's only buying oranges, I'll do the same thing. I'll say y over p naught, or 100 over, for example, 2 in this case, or 50 kgs. We can now plot this information on a graph, because we know this two combinations are, for example, uh, 25 of apples with no oranges, and another combination is 50 of oranges with no apples. So if I put apples on my y-axis and oranges on my x-axis, I will have a linear line, something like this, where one of the points is 25 and another point is 50 here. Now, these are not the only two combinations. There could be some combinations somewhere in the middle as well. For example, one combination, if I use my income of $100 and the price of apple is 4 and orange is 2, is, for example, 12.5 of apples in terms of kgs, and, for example, 25 of oranges. So all of these combinations on the budget line are the ones that are affordable. Any combination of apples and oranges inside, one would argue this, will be affordable but doesn't really end up using our income. But an individual cannot consume any point beyond this. For example, if you tomorrow ask for 25 of oranges and, for example, 25 of apples, that's not possible with the income of $100. Why? Because for that you need 25 times 4, or $100 for apples, plus another 25 times 2, or $50. In other words, you require $150 for a combination like this combination X. So one would argue this, all the points on the budget line can be affordable, while the ones that are beyond it are unaffordable. The next discussion we would like to have is to understand the slope of the budget line, because that will be very useful for us for our later discussion. So the formula for the slope or gradient is always change in y over change in x. If I move from, for example, from 25 apples to 0 apples, but then end up consuming 50 oranges, I will see my slope to become minus 25 over plus 50, or minus half. Now, what does that slope represent? Well, it represents what we call our opportunity cost. In other words, it is telling us for every given orange, how much of apple do I sacrifice? In other words, in this case, we can say for every one orange, you sacrifice half of apple. We can also rewrite this opportunity cost in general form and say the opportunity cost in this case of a budget line is simply opportunity cost of good X in terms of good Y. A useful way to look at our opportunity cost or our slope is also to represent it in terms of prices. If I go back to our calculation of 50, we said that it's simply y over p of orange, and 25 was simply y over p of apple, right? Because price of apple was, for example, $4, 100 over 4 was 25, and similarly 100 over 2 was 50. Now, why am I using this information? Because I found that 25 can be written as y over PA. So I can say this, my slope is simply y over PA divided by change in my x-axis, which is going to be y for income over P naught. If I rewrite this equation, it could be y over PA divided by y over P naught, or in other words, y over PA times P naught over y, and y can get cancelled, and I'm left with P naught over PA, which simply is price of something which is on the x-axis over something which is on the y-axis. Now, what we're trying to say is that the slope of the budget line is simply the ratio of prices, and ratio of prices of good x over good y. And this is useful because when we are going to find out our maximum possible satisfaction, this information will help us generate a point which will incorporate the ratio of prices. So slope of the budget line is simply, in general form, is px over py. Now in the next video, we will be discussing what are the various factors that can result in a shift of a budget line. And this shift can be parallel shift or a non-parallel shift.
If you like the content you just saw and all the other content that is on my website, then you need to head over to allacademy.org, where you will find more content, not only of my subject, but also 5 other subjects. So go there.